This lesson here is exceedingly annoying, so I apologize in advance. It says a U.S. Mint charges $25 for a limited edition coin. There's a limit of 5 coins you can purchase. What's a reasonable domain and range of the function? Is it continuous or discrete? So, you need to find your domain and your range. Okay. Then I need to know if it's continuous. Continuous is on the graph. Okay. It means if you graph this relationship between the coins and the money, would you connect the points or would you not? That's continuous when you connect. It's discrete when you don't. Okay. So those are the two things. Now how we have to get there, there's a quick way, but it's pretty confusing, so I'm going to go the long way and just take my chances. You're going to set up an input-output table. X is your independent variable, Y is your dependent variable. That's nothing new. Now, when you're talking money, what you're paying for, coins is the X, and then the money itself is Y. Now, there's a limit. Limit's 5 coins, so up above coins put limit equals 5. Okay. Now you're going to start at 0 coins. Now if you don't buy any coins, you're not going to have to pay any money. Don't put 25 there. 25 is for the coins themselves. That's when you start buying the coins. So if I buy 1 coin, I would add $25 to my output. If I buy 2 coins, I would add another $25. If I buy 3 coins, I'd add another $25. Now you're like, well, when do we stop this nonsense? Well, when I get to either at the limit of 5 or over the limit 5. So 4 plus 25, that's 100. And then I get to my limit of 5 plus 25, that's 125. That's the end. Now, you're like, do I have to really list all these numbers for the domain? No, you use what's called intervals. You make brackets and you put 0, 5 for the domain. Domain's the X values, 0, 5. Or dash 5, I don't care what it is. Now the range is your Y outputs, okay? 0, 125. Now, is this continuous or discrete? Well, no, if it's continuous, you go under your independent variable coins and put 1.5. Can you buy 1.5 coins from a store? No. So that makes this a discrete graph. Now you're like, well, that's not too bad. Yeah, wait till I do the next 3. I'll be singing a different tune. And these are the problems they gave me in the textbook to go off of. You're buying party favors that cost $2.47 each. You can spend no more than $30 on party favors. What is a reasonable domain and range of this situation? With the function, that means the graph be continuous or discrete. So domain, range. I'm going to put these in intervals rather than have it, so then I don't have to list every number. And then continuous. Because otherwise, if you don't put them in intervals, you get to list every number on the table. I don't really care to do that. This is already going to be crappy enough. So I make my input-output table. X is the independent variable, Y is the dependent variable. X is what you're buying, which would be party favors. And then Y is the money. Now, you're going to need to extend this table, trust me. So and now what's the limit? Now the limit's $30, but that's your money. So limit for money is $30. Okay. Now party favors, 0, 0. If you buy 1, you're paying $2.47. 2, you'd add 2.47, and that's 4.94. You'll have to use a calculator, but to speed this video along, I'm going further. Now, I would separate these with maybe grids like this, okay? I didn't on the last one because I didn't have to go very far, but this one I'm going to. 3 plus 2.47. That's $7.41. 4. You're like, when do I stop? Well, when I cross my limit of 30. Plus, that's what makes it crappy when you have something like this. Plus 2.47, so 5. That takes you to $12.35. You just keep adding the rate of change. 247, 14.82. Plus 2.47, 17.29. Plus 2.47, 19.76. Plus 2.47, it's going to be $22.23. Plus 2.47, $24.70. Plus 2.47, it's going to be $27.17. Plus 2.47, remember the limit's 30. That's $29.64. Then, if I add the 247, that takes me over the limit, so I don't use 13. You can't buy 13. So as soon as you cross over the limit, because that's going to be higher than 30. Now, finally, I'm done with this shenanigans. 0, 12 is the domain. You can buy between 0 and 12 party favors. Range 0, 29.64. Now, when you go to a store, can you buy 1.5 of anything? No, you can't. So that is again discrete. Next one's even worse. A car can travel 32 miles per gallon of gas. The car's tank holds 17 gallons. What is a reasonable domain and range for this situation? Is this function continuous or discrete? Okay. So domain, range. And then I need to determine if it's continuous or discrete. So XY. Now if you're like, what's the X, what's the Y? Well, it's miles per gallon. So I have gallons as X. Miles is Y. Now what's your limit? There is a limit because your tank can only hold 17 gallons. So limit equals 17 for the gallons. Okay. Then as a result, that limits our miles. So if I have 0 gallons of gas, I'm not driving any miles, okay? 1 gallon of gas, okay, 32 miles per gallon, so that means every 1 gallon you can add 32, so 32. 2, as you can see, you can tell why this is going to be crappy. 32 plus 32, 64. Plus 32, 96. So 3 gallons of gas gets me 96 miles. 4 plus 32 is going to be 128. 5 plus 32. 128 plus 32 is 160. 6. And add 32, you're at 192. 7, you add 32, that's 224. 8, you add 32 again, that's 256. 9, you add 32, 256 plus 32 is going to take you to 288. 10, you add 32, 320. Remember, I'm looking for my limit 17 in this column. 320 plus 32 is 352. 12, plus 32 is 384. 13 plus 32, it's going to give you 416. 14 plus 32, 448. 15 plus 32 is 480. 16 plus 32, getting to the end because the limit's 17, is 512. And then finally, 17, which is equal to my limit. If it's equal to the limit, you go through with it. And that's 544. Okay. So the domain, 0 to 17. The range, 0 to 544. Continuous or discrete. Can you have can you pump a gallon and a half of gas? Yeah, you can. So that is continuous. Means if I were to graph all these points, which I'm not going to, okay, I would connect the lines. You have $50 to spend on packages of Halloween candy. Each bag of candy costs $4.99. What's a reasonable domain and range of the function? Is the function continuous or discrete? So domain and range. Then I want to know if we have a continuous or discrete. So XY. So it's a money problem. The thing we're buying, the packages, is the independent variable. And then the money is a dependent variable. So what's the limit? Well, the limit's 50 bucks, okay? That's all we have. $4.99 is the rate of change, okay? So limit $50. So 0 would lead to 0 packages. If I buy one package, well, it would cost me $4.99. 2 packages plus $4.99, that takes you to $9.98. 3 plus 4.99, $9.98 plus $4.99 is going to be $14.97. 4, add 4.99, $19.96. 5, add 4.99, that's going to be $24.95. 6, add 4.99, $29.94. Okay, that's going to be $34.93. Plus $4.99. Really, you can just add $5 to get $39.93, but then subtract 1 cent. Okay. Oh, okay. $39.92. 9 plus $4.99 is going to be $44.91. And then finally, we have 10. That's 49.9. When it's 0.9, you put 90. Okay. Now, if I add another one, I'm over my limit, so I stop there. So it goes from 0 to 10, and then from 0 to $49.90. So continuous or discrete? Well, if I go to a store, I can't buy 1.5 packages. That's not possible. So that would be discrete. Also on number 1, boxes is the X. You're not going to fill you're not going to cut a box in half, okay? So I would call that a discrete. That could be open to interpretation, but we're going to call that one a discrete.